Hey guys, welcome to lesson 9.1, and we are going to be talking about domain and range. We're really going to be digging into that. And there are three situations that domain and range is kind of a big deal. So the first one is when you're dealing with fractions. The second one is when you're dealing with absolute value. And then the third one is when you're dealing with even roots, like square roots, fourth roots, things like that. So we've talked about all of these in the past. So let's really get into the domain and range for each of these. So if you'll remember, we can't have a 0 in the denominator. So x could not equal 1. And then we did like the yucky interval notation there. Oops, sorry, 1. And then the range, y cannot equal 0. For the domain here, notice that the domain is going to go far to the left and far to the right. So the domain for absolute value is negative infinity, positive infinity, but the range is going to start at 0 and go to positive infinity in this case, because we can't have negative numbers with that parent function, negative y values. Okay, and then for the even roots, if you have an odd root, don't forget that your domain and range are both negative infinity, positive infinity. But when you have even roots, remember you have to have a square root underneath the denominator. Sorry, I want to switch that around. You have to have a 0 or greater underneath the denominator. So what we did is we said x minus 1 is greater than or equal to 0, and then solved for that. So here, x is greater than or equal to 1, and then y is 0 or greater. Okay, let's go down to the next part. So all of these should be a review. We're just going to find the domain here. So think about like how each of these pieces are going to affect the problem. So go ahead and push pause and see what you can do on these. Okay, let's go through and talk about each of these. So there are two different things going on here. We can't have a 0 in the denominator, so I got this answer, x cannot equal 6. And then here, we cannot have anything less than 0 under a square root. So that's why x has to be greater than or equal to negative 5. For this one, the only thing that I care about for domain is right there, x has to be greater than or equal, or whatever's under the square root has to be greater than or equal to 0. And so I ended up with this. This one, since it's in the denominator, it cannot equal 0. So it has to be greater than 0. So anytime it's in the denominator, we have to take special account of that. And so instead of having a bracket like we did before, this is going to be parentheses. Okay, let's keep going. So this, we can't have a 0 in the denominator, so I just set it up. This one is, these next few are what we did the other day in our last lesson of in chapter 8. So this has to be greater than or equal to 0, but notice there's an x squared here. So I'm going to go ahead and factor it. And I end up with this situation. So again, it's just like lesson 8.5, and you guys did great on it, so I don't think it should be an issue. Same thing here, so this has to be greater than or equal to 0, so I'm going to factor it. We use the test points, and we go from there. This one is the same way, we just had to factor it, so 2 factors of 4, that adds to give me 5, so that's how I did that one. I found that my 2 critical points were -1 and -4, and I used my test points. And so these, like, the proper answer is in interval notation, but we've done all this before. This is all review, so I kind of went back and forth on that. Notice this one is in the denominator, so it's, instead of like being greater than or equal to 0, it's just greater than 0, and then I'm going to go for there. So that's going to give us a situation with the open dots. And so I'm going to have parentheses. Okay, I'm going to kind of pause here and talk about this one. So I told you that the domain for this one is super easy. it's always going to be negative infinity and positive infinity. But let's focus on the range on this one. So let's kind of dig into this. So I know that this has to be greater than or equal to 0. So let's kind of stop there and wrap our mind around that. Okay, so we know that. I'm also going to solve for this. So I'm going to say, I'm going to move that 2 over. So y plus 2 divided by -5 is equal to the absolute value of x minus 3. Well, I just said that the absolute value of x minus 3 has to be greater than or equal to 0. So now I'm going to say that this has to be greater than or equal to 0. If one side has to be greater than or equal to 0, the other side has to be greater than or equal to 0 because they're equal to each other. Okay, so let's go ahead and solve for y. So y plus 2 is less than or equal to -5 because I'm multiplying both sides by -5. And so I had to switch the sign. And then I'm going to subtract 2. Sorry, I can't multiply 0 times -5. 0 times -5 is 0. Okay, and then I'm going to subtract 2. So I have y is less than or equal to -2. So this is going to be our range. So our range is going to be from negative infinity to -2. And we're going to go with that. So we are going to be talking about inverse functions. So what if I flipped this x and this y? So what if I flip that? So let me show you what that's going to look like. Okay, it would look something like this. So if I have a absolute value function and it's negative, we know that like our vertex is going to be at 3, -2, and it's going to be skinny because it's 5 and it's going down. So it would look something like this. If I were to flip this, it would look like this. Okay, so let's kind of talk about when we flip the x and y. So notice instead of going down, now we're pointing to the left. So it's kind of sideways from the original one. Notice our vertex, instead of it being 3, -2, it's -2, 3. So that's flipped. And in addition to that, our domain and range is going to be flipped. So if I look over here, if I can find it, right here, I had my domain be negative infinity, positive infinity. So when I flip the x and y, my range now is going to be negative infinity, positive infinity. And then my domain is going to be what my range was. So my domain now is going to be x, x is less than or equal to -2. So let me show you, kind of remember this. So range is negative infinity, positive infinity, and our domain is x has to be less than or equal to -2. So let's look at our Desmos and see if that makes sense. So our range, notice this is going to go up, 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 and down, down, down. So that makes sense. And then our domain has to be less than or equal to -2, which hopefully makes sense from here. Also notice this is no longer a function because it doesn't pass the vertical line test. So we're going to be asked some questions whether or not it's a function, and this is definitely not a function anymore. Okay, so this one is very similar to the one that we just did. And so I know that it's not a function, so I'm going to say not. Okay, so let's think about the domain and range. So remember, the range, when it's flipped on an absolute value, our range is going to be negative infinity to positive infinity. And so now we're going to have to work for our domain. Okay, so I went through the work just like we did last time. So I went ahead and isolated the y plus 6 in the absolute value. And so I subtracted, I added the 5 and divided by 2. And I knew that that had to be greater than or equal to 0. So I just went from there and solved. I know that my domain is going to be bracket -5 to positive infinity. Okay, so notice that this is just your regular plane chain quadratic. So it's going to go down like that. My vertex is at 2, 5. Oops. And so the domain and range should be pretty easy here. So definitely, yes, it is a function. My domain is -infinity to positive infinity, and my range is going to be -infinity to 5, how high it goes. Okay, so let's think about when it's flipped. So let's just look at the graph and see if we can figure out the domain and range. So the range is going to be -infinity, positive infinity now, and my domain is going to be 5 to infinity. So notice if I just pretended that this was a regular, like y equals x squared and went from there, it'd be a regular parabola. And notice my domain would be -infinity to positive infinity, and my range is 5 to positive infinity. So literally when you flip the x and y, you flip the domain and range. So however kind of mentally you want to wrap your mind around that. So our new domain is going to be 5 to positive infinity, and our new range is going to be -infinity to infinity. Okay, so let's take a fraction. So we talked about fractions, like you can't have a 0 in the denominator. So in this case, x cannot equal 2, so that would be my domain. And my range is y cannot equal 0, and it is a function. Okay, so when I flip the x and y, I'm going to think about the domain and range being flipped. So my domain now is y cannot equal 0, and my range is going to be, sorry, this is x cannot equal 0, and my range is going to be y cannot equal 1. And in this case, it's not going to be a function. Okay, so let's talk about square roots. So in a normal situation, our domain, we're going to get it from here. So x minus 11 has to be greater than or equal to 0. So x is greater than or equal to 11. And then our range, remember this -infinity to 5. And so when we flip the x and y, just think about flipping that thought process. So this now is going to be our range. So I'm going to say y plus 4 has to be greater than or equal to 0. So y has to be greater than or equal to -4. That's our range. And our domain now is going to be -2 to positive infinity. This one is the same way. So our domain is going to be our range, and our range is going to be our domain. So our range, we're going to have y minus 3 has to be greater than or equal to 0. So y is greater than or equal to 3. And my domain is going to be positive, or 4 to positive infinity. Okay, this one, notice how it has an odd root. So my domain and range are both -infinity to positive infinity. And it doesn't matter if it's y or x, if they're flipped, it's going to be the same. And we are done.